Dear students, welcome to the video hypothesis testing with the Poisson distribution. Example 1. Records show that 1% of the population has a positive reaction to a test for a particular allergy. In a village, 120 people are tested and 4 people have a positive reaction. Test at 5% level of significance if there is any evidence of an increase in the population with a positive reaction for this particular allergy. So let x be the number of people showing reaction to this type of allergy. So x will have binomial distribution with 120 as n and 0.01 1% as probability of success. As here n is greater than 50 and np is less than 5, so it can be approximated by Poisson distribution. So x, let me write it here, it can be approximated by Poisson distribution with 1.2, which is your np, as lambda, the parameter of the Poisson distribution. Now, so your null and alternative hypothesis. So for the null, let lambda be equal to 1.2, and it says increase, so lambda is greater than 1.2 is alternative hypothesis. So it says there are 4 people that have a positive reaction, so and it says increase, so we should calculate the probability of x greater or equal to 4, which is equal to 1 minus probability of x less or equal to 3. So 1 minus e to the power of negative 1.2 is factored, then 1.2 to the power of 0 over 0 factorial plus 1.2, 1 factorial plus 1.2 to the power of 2 over 2 factorial plus 1.2 to the power of 3 over 3 factorial. Finally, it will give you 1 minus 0.9662, which is equal to 3.38%. Now, as 3.38% is less than 5% level of significance given in the question, so it lies in the rejection region. So the conclusion is that there is some evidence to reject HO. HO should be rejected, or there is some evidence to accept H1. Example number 2, accidents on a stretch of road occur at the rate of 7 each month. You see, information given in the question indicates that you have Poisson distribution. New traffic measures are put in place to reduce the number of accidents. In the following months, there are only 2 accidents. Part A tests at the 5% level of significance if there is evidence that the new traffic measures have significantly reduced the number of accidents. Part B, over a period of 6 months, and see here your lambda should be updated because it is 1 month, it is for 6 months. There are 32 accidents. It is claimed that the new traffic measures are no longer reducing the number of accidents. Part I tests this claim at the 5% level of significance. Second part, what would your conclusion be if you tested the claim at the 10% level of significance? Okay. Now, part A, x has Poisson distribution with 7 as the lambda. Now your null hypothesis, lambda is equal to 7 and alternative lambda is less than 7, as it says it's going to reduce. Now there are two accidents in the following month, so probability of x less or equal to 2 will be equal to e to the power of negative 7 factorial 7 to the power of 0 over 0 factorial plus 7 to the power of 1 over 1 factorial plus 7 to the power of 2 over 2 factorial, which will be 0.0296, equivalent to 2.96%. Level of significance was 5%, so it is less than 5%. So here there is some evidence to reject HO, or it means that there is some evidence to show that the new measures, traffic measures, is reducing the number of accidents. Part B, over a period of 6 months. So do not forget to update your lambda. So the new lambda will be 6 times 7, which is 42, and is greater than 15. So as we know, x has Poisson distribution with 42 as the lambda. It can be approximated by normal distribution with 42 as mean and variance both, as it is greater than 15. Now your null hypothesis, mu is equal to 42, and h1, or alternative mu, is less than 42. Now it says there are 32 accidents, so we calculate probability of x less or equal to 32, which is equal to, after doing continuity correction, x after actually standardizing, it will be less or equal to 32.5 minus 42 over root 42. It will be phi of negative 1.466, giving you an answer of finally 0.0713. So which is equal to 7.13%, greater than 5% level of significance. So it is in acceptance region. So here you can actually accept HO or reject H1, or you can say that these new traffic measurements are no longer reducing the number of accidents. Now for the second part, part B, it says that if your level of significance is 10%, so here 7.31% will be less than 10%, which is significance level. So it will be in the rejection region. When it says in rejection region, so HO is rejected and H1, alternative hypothesis, will be accepted. Or you can say that these new traffic measures is actually reducing the number of accidents.